If the limit as x goes to a of f of x is m, and the limit as x goes to a of g of x is n, then the limit of the quotient f of x over g of x is m over n, as long as n is not 0. In this video, we will examine what happens if n is 0 and m is not 0. The example we will consider is the lim as x goes to 1 plus of 2x plus 3 over x minus 1. Note that the limit of the top is 5 and the limit of the bottom is 0. So this is exactly the sort of limit we should be looking at. So let's do some numerical calculations. We take x close to 1, but a little larger than 1, which is what x goes to 1 plus means. So when x is 1.1, x minus 1, the denominator is 0.1, the numerator is 5.2, and the ratio is 52. As we let x get closer to 1, x equals 1.01, x minus 1 is 0.01, the numerator is 5.02, and the ratio is 502. Again, letting x get closer, x is 1.001, which means the denominator is now 0.001. The numerator is 5.002, and the ratio is now larger than 5,000. As we let x get closer and closer to 1 from above, we note that the denominator gets closer and closer to 0 from above. The numerator gets closer and closer to 5, but the ratio becomes very large. The values of the quotient do not approach a single number. Thus, the limit does not exist. However, since the quotient values get arbitrarily large and positive, we can use the symbol plus infinity to describe how this limit fails to exist. Keep in mind again, plus infinity is not the value of the limit. It is a symbol explaining why the limit doesn't exist in a particular fashion. Let's try to do the same problem now without actually doing any numerics. So again, we note that as x goes to 1 from above, 2x plus 3 looks a lot like 5, and x minus 1 looks a lot like 0. However, since x is slightly larger than 1, x minus 1 is slightly larger than 0. So we write the limit equals, quotes, 5 over 0 plus. The quotes indicate that this is not actually the limit. This is how we are thinking about it. Okay, so we have a number that looks like 5 divided by a very small positive number, which is going to be a number large in magnitude. And since both the top and the bottom are positive, the ratio is positive, which means our limit is plus infinity. If we now look at the limit as x goes to 1 minus, this is values of x approaching 1 but from below, less than 1. The limit of the top is again 5. However, the limit of the bottom is 0 minus, meaning that x is a little less than 1, so x minus 1 is a little less than 0. So we're getting 5 divided by a number very close to 0. However, that number is a negative number, and positive divided by negative is negative, and the magnitude is huge, so our limit this time is minus infinity. Note that because we have to use different symbols when x goes to 1 plus and when x goes to 1 minus, there's no single symbol we can use for x goes to 1, so we write the limit as x goes to 1 of 2x plus 3 over x minus 1 does not exist. Okay, let's look at a second problem. Limit as x goes to 2 plus of x minus 4 over 4 minus x squared. We do the same sort of analysis. Notice that the top looks like minus 2. 2 minus 4 is minus 2. The bottom looks like 0. But again, because x is slightly bigger than 2, x squared is slightly bigger than 4, and 4 minus something slightly bigger than 4 is negative. So we've got minus 2 over 0 minus, and that limit is thus plus infinity. Note that I have just written infinity here. The default is if there's no plus or minus in front, it's plus, just like 4 is really plus 4. Okay, let's look from the other side. The limit as x goes to 2 minus of x minus 4 over 4 minus x squared is minus 2 over 0 plus. Again, here we look at x, and x is a little less than 2, so x squared is a little less than 4. 4 minus x squared is thus positive, so we've got minus 2 over 0 plus. Minus divided by plus is minus, so this limit is minus infinity. Again, since we have to use different symbols on both sides, we end up with the limit as x goes to 2 of x minus 4 over 4 minus x squared does not exist. There's no single symbol we can write that indicates why it doesn't exist. Okay, last example. The lim as x goes to minus 1 of x over x plus 1 squared. Okay, here we're going to go the lim as x goes to minus 1 minus, and now lots of minus signs. But the idea here is that x is a little less than minus 1, which means x plus 1 is a little less than 0. You square, however, something a little less than 0, you get something a little bigger than 0. So we end up writing minus 1, which is where the top goes, over 0 plus. And now negative divided by positive is negative, so this limit should be minus infinity. We look from the other side. The lim as x goes to minus 1 plus. Here, x is a little bigger than minus 1, which means that x plus 1 is a little bigger than 0. Square it, again, positive number, a little bigger than 0. Top looks like minus 1. Minus 1 over 0 plus gives us minus infinity. And since we can use the same symbol for both one-sided limits, we can write the lim as x goes to minus 1 of x over x plus 1 squared is minus infinity.